Alright, this is my 555 based PWM motor controller. It's a 100K pot. Circuit itself's running off of a 9-volt battery. Can range from like 3 to 18 volt DC. I got 2 transistors there, or not really transistors, the N-channel MOSFETs. One can handle the total current load of this Magmotor here, but I figured I had a second one, so identical matching one, and I might as well just put them in parallel, just for safety's sake. Plus that gives me more options with motors. These are really nice end channels too, because the data sheet says they only output 50 watts of heat. While this one here, which is the original one I was using, it put out 125. This one here, though, it put out 60 amps by itself. These put out 40, but in parallel like that, it's probably going to put out 80. That's how most things work in electronics. Anyway, here's the 555. It's a KA555N, pretty sure. Doesn't really matter about that though. Then I got two 12-volt deep cycle lead acid batteries that I pulled out of a moped, or not moped, a scooter years ago. Pretty sure like 10 amp hours a piece. I have them wired in parallel, so pretty nice. Really heavy too. Alright, anyway, this is a test motor I was playing with, and the circuit and a lot of the lights are probably going to run off of this motor when I'm done. This is a 6.7 volt DC motor with 5 amp hours. I figured I'll be able to drive this circuit, maybe a headlight or some kind. If not, I can always work around that. I just want to use this from here for the motor only. And if you can't tell by looking at the breadboard, I have it wired. This is a switching end channel, just to turn them. Basically it's a variable power supply. But yeah, I got a really small diode there. It's the flyback diode. I'm gonna have to get a bigger one. I have a few, but they don't seem to be big enough. Bench test to this motor. At full speed, 12 volts, it draws 3 amps, and under complete stall it's about 10. And like I said, these can handle 40 amps a piece wired in parallel. It's going to be about 80. And about 60 volts DC, which is nowhere near what I'm running. Anyway, let's fire it up. Alright, power LED. Sure it's working. Alright, let's get this going. That's full power. Get this wire. And I have yet to actually determine how many amps the motor is pulling right there. I just haven't put it in series yet, the meter, which I guess I can do that now. I need an alligator clip. Hold on. Okay. I just got a cheap little meter here I got from Harbor Freight. I'm not going to stall it though, because this meter is only rated for 10 amps. And I don't have a good one now that can handle 20. But this should easily be able to tell us the current that this motor is pulling. So let me hook this back up. And I probably should have put a switch in line with this. Okay. all the way up, about 2.5 amps. You can see it's draining pretty quick. So probably means I'm not going to be able to use this motor, or just that the batteries died on me. I haven't charged them since last night. Let me take the meter and I'll test the voltage levels of it. Yeah, see, the voltage dropped pretty quick on that. But yep, that's the circuit there. Probably gonna be some future improvements, like a heavy diode between the circuit and the transistors and channels, just in case for some reason if a surge of current blows them, doesn't ruin the rest of the circuit. And I was thinking about using 2 of these, which these are just standard plug connections for a computer, for a fan. Transistors and stuff seem to fit real nice into them. I was thinking about using that so I can plug and swap transistors. They seem to fit really nice. And I've checked connections and everything, and they're all good. But I was thinking about doing that. But with these leads on these right there, they're really small. I salvaged them out of this board here, which was actually, it came out of the same screw the batteries came out of. But it's a speed controller. The reason I didn't use is, 1, probably draws a lot of power. 2, I have no clue where anything goes. I couldn't find any information on it. And 3, there's supposed to be a heat sink that covered this entire thing, so I'm sure if I actually got it working, it would catch fire or something. But yep, that's it. And yep, that's it.